Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than?
Chinese researchers have achieved a significant milestone in the race for semiconductor supremacy. Led by Lin Nan, a team from the Chinese Academy of Sciences Shanghai Institute of Optics and Fine Mechanics has developed an extreme ultraviolet EUV light source platform that operates at internationally competitive parameters. This breakthrough marks a pivotal step toward China's self-sufficiency in producing advanced chips, sending shockwaves through the global semiconductor industry. The stakes couldn't be higher. EUV lithography is the key to unlocking the next generation of semiconductors, enabling the fabrication of chips with nodes below 7 nanometers. These cutting-edge chips promise unparalleled power and efficiency, forming the backbone of everything from smartphones to supercomputers. Until now, only one company in the world, Dutch giant ASML, possessed the technology to manufacture EUV machines. But with US-led export restrictions barring ASML from selling its most advanced models to China since 2019, the country has been left scrambling to develop its own alternatives. Enter Lin Nan and his team of trailblazing researchers. Details of their EUV platform remain closely guarded, but insiders suggest it could be a game-changer. The implications are profound. China currently accounts for over 40% of ASML's global sales, underscoring the country's critical role in the semiconductor supply chain. But with each passing year, the noose of export controls tightens further. In September 2023, under intense pressure from the US, the Dutch government imposed even stricter limitations on the lithography machines available to Chinese chipmakers. The move sparked a frenzied rush of orders from China as companies raced to secure equipment before the restrictions took hold. The stakes extend far beyond the realm of technology. As the United States ramps up its efforts to constrain China's access to advanced computing and semiconductor manufacturing capabilities, the geopolitical landscape grows increasingly complex. Effective October 7, 2022, a sweeping set of export controls aim to curtail China's ability to obtain, develop, and manufacture cutting-edge semiconductor technology. From AI chips to design tools, the measures seek to hamstring China's progress in critical sectors. For companies like ASML, caught in the crosshairs of this technological arms race, the path forward is fraught with uncertainty. CEO Christophe Fouquet has openly voiced his concerns about the mounting pressure from the United States, anticipating further restrictions on the horizon. While ASML expects to weather the storm in the short term, with China still accounting for around 20% of its projected sales in 2025, as China pours resources into developing domestic alternatives, the global semiconductor supply chain is poised for a seismic reconfiguration. In the near term, export restrictions may lead to disruptions and increased costs for manufacturers worldwide. But if China succeeds in its quest for self-sufficiency, it could fundamentally reshape market dynamics, eroding the dominance of established players like ASML. The road ahead is long and arduous. Translating laboratory breakthroughs into commercially viable, mass production-ready systems is a monumental challenge. It will require sustained investment, unwavering determination, and a healthy dose of ingenuity. But if there's one thing China has proven time and again, it's the ability to mobilize resources and talent on an unparalleled scale. As the world watches with bated breath, one thing is clear: the semiconductor industry is at an inflection point. The outcomes of China's self-sufficiency drive will reverberate far beyond the confines of the clean room, influencing everything from the balance of technological power to the future of global trade. In this high-stakes game of geopolitical chess, every move carries profound consequences. The question is, who will emerge victorious in the battle for the Silicon frontier? The tech world stands breathless as Chinese telecommunications titan Huawei prepares to unleash its revolutionary Ascend 9 AI chip into global markets next month. This jaw-dropping development has already sent Nvidia, America's undisputed AI chip champion, reeling. with an eye-watering $127 billion vanishing from its market value in just 24 hours. The question on everyone's mind: is this the beginning of the end for America's semiconductor supremacy? The announcement couldn't have come at a worse time for Nvidia, which had recently been barred from selling its flagship H100 chip to Chinese customers due to tightening U.S. export controls. The Trump administration's message was clear. America intended to maintain its chokehold on advanced AI computing power in China. But Huawei had a surprise in store, a homegrown alternative that not only rivals, but in some aspects. What makes this achievement even more remarkable is that Huawei accomplished this feat while cut off from the advanced manufacturing technologies that Nvidia relies on. The 910C's arrival couldn't be more timely for Chinese AI companies, which have been scrambling for alternatives since the United States restricted sales of Nvidia's chips. But the path to mass production hasn't been without its challenges. Huawei's manufacturing partner, Semiconductor Manufacturing International Corp., SMIC, is producing the chip using its 7nm N+2 process. But the lack of access to advanced lithography equipment has resulted in yields of only around 20%, far below the 70% typically required for commercial viability. Despite these hurdles, Huawei remains undeterred. The company has already begun distributing samples and accepting orders for the 920NC, with plans to ramp up production to 100,000 units within the year. This ambitious target reflects Huawei's determination to solidify its position in the AI chip market and reduce China's reliance on foreign technology. The geopolitical implications of Huawei's breakthrough are profound. As the battle for AI supremacy heats up between the US and China, the 910C's emergence marks a significant shift in the balance of power. For Nvidia, the road ahead looks increasingly uncertain. With its access to the lucrative Chinese market now severely curtailed, the company must grapple with the prospect of a formidable new rival on the global stage. As Huawei navigates manufacturing challenges and geopolitical tensions, its progress will be closely watched by industry stakeholders and policymakers alike. The Ascend 910C's impending mass production represents not just a triumph of engineering, but a symbolic victory in China's quest for technological independence. In the high-stakes game of AI dominance, Huawei has just played a winning hand.
Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than
The moment Huawei's executives walked onto that Shanghai stage in May 2025, they weren't just unveiling new laptops, they were declaring war on the entire personal computing industry. With a single product announcement, the Chinese tech giant shattered decades of Microsoft and Apple dominance, introducing something the world had never seen: laptops running entirely on their own operating system, built from the ground up to challenge everything we thought we knew about personal computers. 23,999 yuan. That's what Huawei is charging for a laptop that folds like a book, weighs barely more than a kilogram, and runs on an operating system that didn't exist in the PC world just months ago. The MateBook Fold isn't just another foldable device. It's a technological declaration of independence wrapped in an 18-inch OLED display that blazes at 1,600 nits of brightness. But here's what makes this truly extraordinary. When you unfold this 7.3mm thin marvel, you're not greeted by Windows or Mac OS. Instead, you're looking at Harmony OS 5. An operating system that began life-powering smartphones and has now evolved into something far more ambitious. Today, it powers over 1 billion devices worldwide, and it's coming for the PC market that 2 American companies have controlled for decades. The timing couldn't be more critical. When US sanctions cut off Huawei's access to critical technologies from Intel and Qualcomm in May 2024, most observers expected the company to struggle. This wasn't a rushed response to trade restrictions. It was a calculated revolution 5 years in the making. Over 2,700 core patents, more than 10,000 engineers working around the clock, collaboration with over 20 research institutions, and billions of dollars in research and development. The numbers tell the story of a company that didn't just adapt to isolation, they transformed it into an opportunity to build something unprecedented. The MateBook Pro, starting at 7,999 yuan, brings this revolution to the masses. While it maintains a more conventional laptop design, what's running underneath represents anything but business as usual. With 32 gigabytes of RAM and up to 2 terabytes of SSD storage, these machines aren't just alternatives to Windows laptops. They're designed to outperform them in key areas where traditional operating systems have shown their age. What makes this particularly fascinating is how Huawei approached the software ecosystem challenge. Rather than trying to replicate Windows or Mac OS, they created something uniquely their own. Harmony OS 5 currently supports over 150 applications natively, with aggressive plans to expand to 2,000 by year's end. This isn't about playing catch-up. It's about reimagining what a PC operating system should be in 2025. The artificial intelligence integration takes this even further. Celia, Huawei's AI assistant, doesn't just respond to voice commands. It actively helps create presentations, summarizes meeting minutes, and retrieves information from local documents with contextual understanding that puts traditional assistants to shame. This shift carries massive implications for global technology. For decades, the PC market has been essentially a duopoly, with Windows commanding over 70% market share and Apple taking most of the premium segment. Now, a third player has entered the arena, and they're not playing by the established rules that have governed personal computing since the 1980s. The security implications alone are staggering. By developing their own operating system from scratch, Huawei eliminates concerns about backdoors, data leakage, and foreign surveillance issues that have become increasingly critical in our interconnected world. Government agencies and enterprises dealing with sensitive information now have an option that keeps their data entirely within their control, free from the oversight of foreign corporations or governments. But perhaps the most intriguing aspect is how this fits into Huawei's broader ecosystem strategy. These aren't standalone devices. They're part of an interconnected web of products that communicate seamlessly across platforms. Imagine dragging a file from your smartphone to your laptop with a simple gesture, or continuing a video call from your tablet to your PC without missing a beat. This isn't theoretical. It's happening right now in offices across China. The foldable MateBook represents something even more ambitious than traditional computing. With its 3.3K resolution OLED display and innovative water drop hinge design borrowed from Huawei's smartphone innovations, it's not just about having a bigger screen, it's about reimagining how we interact with our computers. The device transforms from a 13-inch portable to an 18-inch workstation, challenging fundamental assumptions about what a laptop should be. The implications extend far beyond Huawei itself. Other Chinese technology companies are watching closely, and some are already exploring similar paths toward technological independence. If Huawei can successfully challenge the Windows-Apple duopoly, it opens the door for others to follow. We could be witnessing the beginning of a fundamental shift in how personal computers are designed, built, and operated globally. The economic ripple effects are already being felt across the industry. Component suppliers who once relied heavily on traditional PC manufacturers are now recalibrating their strategies entirely. In Shenzhen's electronics markets, where trends often predict global shifts, vendors report unprecedented interest in Harmony OS-compatible peripherals. Mouse and keyboard manufacturers are rushing to ensure compatibility, while software developers are pivoting resources to create native applications. The ecosystem that took Windows decades to build is being reconstructed at breathtaking speed. What's particularly striking is how Huawei has turned technological isolation into innovation acceleration. When access to Google mobile services was severed in 2019, pessimists predicted the company's inevitable decline. Instead, Huawei developed HMS Core, which now serves 730 million active users globally. That same resilience and ingenuity is now being applied to the PC market, with potentially far-reaching consequences that could reshape the entire industry. But success in the laboratory doesn't guarantee victory in the marketplace, and Huawei faces challenges that could determine whether this technological revolution transforms into a genuine market disruption. The first hurdle stands 12,000 miles away in Washington, where policymakers are already scrambling to understand the implications of a major American technology sector facing its first serious challenge in decades. The Biden administration's response has been swift and telling. Within weeks of Huawei's laptop announcement, the Commerce Department initiated preliminary discussions about expanding export controls. This reaction reveals something profound about how the global technology landscape has shifted. For years, American sanctions were seen as devastating because they cut companies off from essential ecosystems. Now, those same restrictions may have inadvertently forced the creation of entirely parallel technological infrastructures. The numbers emerging from Huawei's supply chain paint a remarkable picture of this independence. 93% of components in the new MateBook series are now sourced from Chinese manufacturers, compared to just 41% 3 years ago. The Kirin processors powering these devices are fabricated entirely within China using 7nm technology. Yet here they are, delivering performance benchmarks that rival Intel's latest offerings. More telling is what's happening in software development. Major Chinese applications are rapidly porting to Harmony OS, not as an afterthought, but as a priority platform. WeChat, DingTalk, and Tencent Meeting have all announced native versions optimized specifically for the new operating system. International software companies face a more complex calculation. Adobe has quietly begun exploring Harmony OS compatibility for its Creative Suite. The consumer response has been equally revealing. Pre-orders for the MateBook Fold exceeded 50,000 units within the first week. More significantly, corporate customers are driving much of this early demand. State-owned enterprises across China have begun pilot programs, and several major private corporations have announced plans to transition entire departments. This enterprise adoption matters enormously because it addresses one of the fundamental challenges facing any new computing platform: critical mass. When employees use Harmony OS at work, they become familiar with the interface, understand the capabilities, and often desire similar functionality in their personal devices. This creates a virtuous cycle that no amount of marketing can manufacture artificially. The international implications grow more complex by the day. European telecommunications companies, already heavily invested in Huawei's 5G infrastructure, are now evaluating these laptops for their own workforce needs. This sentiment reflects a broader shift in how global companies think about technology dependency. The repeated use of American technology platforms as instruments of foreign policy has created demand for alternatives that many didn't anticipate. Huawei's timing, whether intentional or coincidental, aligns perfectly with this growing appetite for technological diversification. The moment China unveiled its anti-stealth radar at the World Radar Expo in Hefei, the Pentagon's decades-long advantage in stealth technology began to crumble. This wasn't just another military showcase, it was a declaration that the invisible had become visible, and the hunters had become the hunted. Picture this. American F-35 fighters, each costing over $100 million, suddenly vulnerable to detection by Chinese radar systems that can spot them from hundreds of miles away. The stealth aircraft that once flew undetected through enemy airspace now face a new reality where their primary advantage has been neutralized. At the heart of this transformation stands the JY-27V, a meter-wave radar system that rewrites the rules of aerial warfare. Unlike conventional radars that stealth aircraft can evade, this system operates on longer wavelengths that make radar-absorbing materials ineffective. Within 10 minutes, military operators can deploy this mobile giant, its massive array unfolding like a technological predator preparing to hunt. The system's intelligent algorithms don't just detect, they predict, tracking flight patterns and anticipating evasive maneuvers before pilots even execute them. When we first saw the data, we couldn't believe it, recalls Dr. James Morrison, a former Pentagon radar specialist. They weren't just matching our capabilities, They were creating detection methods we hadn't even considered. It's like they found a backdoor we didn't know existed. The numbers paint a stark picture. Over 100 advanced radar systems filled the expo floor, each representing years of compressed innovation. The JY-11 system alone can simultaneously track fighter jets, cruise missiles, and micro-drones smaller than a dinner plate. Its three-face array provides 360-degree coverage, creating an impenetrable dome of detection that extends from ground level to the edge of space. But these radars do more than just see, they think. Artificial intelligence processes incoming signals in real time, distinguishing between actual threats and false echoes. Birds, weather phenomena, and electronic interference that once confused older systems now get filtered out instantly. The result is a clarity of battlefield awareness that transforms defensive capabilities into offensive advantages. The YLC-12 system takes this even further, specifically designed to counter the low-altitude penetration tactics that NATO forces have perfected over decades. Flying beneath radar coverage no longer offers protection when these systems can detect objects skimming just meters above the ground. Military planners who spent careers developing low-altitude attack profiles now face the sobering reality that their playbooks have become obsolete. International buyers lined up at the expo, eager to acquire these game-changing capabilities. Representatives from Southeast Asia, the Middle East, and Africa examined specifications that promised to level playing fields previously dominated by Western air power. For the first time in history, noted one African defense minister, smaller nations can afford technology that neutralizes the stealth advantage of major powers. The implications ripple through every military headquarters from Washington to London. Trillion-dollar investments in stealth technology suddenly face questions about their continued relevance. The F-22 Raptor, once considered invincible in aerial combat, now operates knowing that Chinese radars might be tracking its every move. The B-2 Spirit bomber, designed to penetrate the most sophisticated air defenses, confronts detection systems specifically engineered to spot its unique radar signature. Yet the real revolution extends beyond military applications. CETC demonstrated weather radars at Beijing Daxing International Airport that provide meteorological data with 75-meter resolution, precision that enhances flight safety, while showcasing dual-use technology that blurs civilian and military capabilities. The same expertise that tracks stealth fighters now guides commercial aircraft through storms, demonstrating how military innovation cascades into civilian benefits. The expo also revealed China's integration of radar technology with emerging 6G communications. Experimental systems demonstrated ranging accuracy within 4 centimeters, while simultaneously transmitting data at speeds that make current 5G networks look sluggish. This convergence of detection and communication technologies creates possibilities that defense planners are only beginning to comprehend. Imagine every radar installation also serving as a communications node, explains Dr. Sarah Chen, a telecommunications expert at MIT. You're not just building a detection network, you're creating an intelligent grid that shares information instantaneously across thousands of miles. It's a fundamental reimagining of how military infrastructure operates. The speed of development stuns even Chinese engineers. Where American stealth technology evolved over decades of careful iteration, Chinese counter-stealth capabilities compressed similar advancement into just a few years. This acceleration reflects not just technological prowess, but a different approach to innovation, one that emphasizes rapid prototyping, accepts higher failure rates, and iterates at speeds that traditional defense contractors cannot match. Foreign military delegations at the expo faced an uncomfortable truth. The stealth advantage that justified massive defense expenditures had evaporated almost overnight. Aircraft designed to operate in contested airspace now faced detection systems that could track them from the moment they took off. The psychological impact alone reshapes military thinking. Pilots who once felt invisible now fly knowing that someone, somewhere, might be watching. The export potential of these systems threatens to democratize what was once exclusive technology. Countries that could never afford American stealth aircraft can now purchase Chinese radars that neutralize that advantage. This proliferation doesn't just change regional power balances. It fundamentally alters how military forces think about air superiority and strategic planning. As the expo concluded, one thing became crystal clear: the age of guaranteed stealth had ended. In its place emerged a new reality where detection and evasion would become an ever-escalating technological arms race. But China had seized the initiative, transforming from a nation that once struggled to detect conventional aircraft into one that could spot the most advanced stealth platforms ever created. The transformation didn't stop at the expo floor. Within months, Chinese radar installations began appearing along disputed borders and artificial islands, creating an interconnected web of detection that stretched across the Indo-Pacific. Each installation represented another node in what military analysts now call the Great Wall of Electromagnetic Waves, a barrier that makes undetected aerial intrusion virtually impossible. American military exercises in the region took on a surreal quality. Pilots flying fifth-generation fighters reported unusual experiences, warning systems lighting up in international airspace, indicating they were being tracked by sources they couldn't identify. "It's unnerving," admitted Lieutenant Colonel Marcus Thompson, speaking on condition of anonymity. "You're flying what's supposed to be an invisible aircraft, but you know someone's watching. It changes everything about how you approach a mission." The technological leap becomes even more impressive when examining the miniaturization achievements. Chinese engineers compressed capabilities that once required building-sized installations into mobile units that fit on standard military trucks. The YLC-48 system weighs just 8 tons, yet delivers detection capabilities that rival fixed installations weighing hundreds of tons. This mobility means radar coverage can shift and adapt, creating unpredictable detection zones that keep adversaries guessing. Behind these achievements lies a fundamental rethinking of electromagnetic physics. While Western engineers focused on making aircraft invisible to specific radar frequencies, Chinese researchers explored the entire electromagnetic spectrum. They discovered that stealth aircraft, while invisible to X-band radars, create distinctive signatures in other wavelengths. By combining multiple frequency bands and using advanced signal processing, they could reconstruct a complete picture of supposedly invisible aircraft. The economic implications prove equally staggering. Nations that invested billions in stealth aircraft now face depreciated assets. Saudi Arabia's purchase of F-35s, totaling $28 billion, suddenly seems less prudent when potential adversaries can acquire detection systems for a fraction of that cost. Insurance companies have begun recalculating premiums for military aircraft, acknowledging that stealth no longer guarantees survivability. Chinese radar development also revealed an unexpected advantage in their educational system. Universities in Beijing, Shanghai, and Chengdu produce thousands of electromagnetic engineering graduates annually, creating a talent pool that dwarfs Western capabilities. We're seeing PhD-level research being conducted by undergraduate teams, observed Professor Michael Harrison from Stanford. They have the numbers, the funding, and most importantly, the national motivation to push boundaries we thought were fixed. The integration with artificial intelligence adds another layer of capability. These radars don't just detect, they learn. Each flight pattern, each evasive maneuver gets recorded and analyzed. Over time, the systems build profiles of different aircraft types, pilot behaviors, and tactical approaches. A Chinese radar operator today has access to a database of knowledge that would have required decades of human observation to compile. Real-world testing accelerated these developments. The South China Sea became a laboratory where Chinese radars tracked every military flight, building an unprecedented dataset of stealth aircraft behaviors. American B-2 bombers flying from Guam, F-35s operating from Japanese bases, and even experimental aircraft undergoing testing all contributed unknowingly to improving Chinese detection algorithms. The commercial spillover effects multiply daily. Chinese automotive companies now incorporate military-grade radar technology into autonomous vehicles, achieving detection capabilities that surpass Western competitors.